Great. So when I came here from Birmingham this morning, I was reading The Voyage of the Beagle by Charles Darwin, and I think it's a great book. It's really fascinating how he describes his travels around the world and how he links that with scientific findings. And I was also wondering when I read this, like how different is science today? I couldn't go on a boat and travel for 5 years and then take 23 years to publish his findings. So I'm a scientist, and when I was invited to give this talk here, I was thinking, am I a storyteller too? I wasn't so sure, but then I went to look for a picture to put in my presentation, and then I noticed that, well, maybe I do use my hands a lot and try to visualize things, so maybe. But what is sure is who I learned this from. You might have already recognized him. So thanks very much, Roel, for the invitation, and also congratulations with your Teacher of the Year award. I think it's great and well deserved as well. So I will be hopefully telling you some stories tonight, and I'm going to talk about drought in the Anthropocene. And well, I assume that you know what drought is. Simply said, a lack of water compared to normal conditions. But what is the Anthropocene? So we've already heard about different geological timescales, like the Eemian. There's loads of different ones that are like the whole geological time period of millions and billions of years has been subdivided into eras, periods, and epochs that are really distinct periods with distinct characteristics. And they have been alternating in time. And a few weeks ago, there was, you might have read it in the news, that there was a proposal for a new geological period called the Anthropocene to the committee that actually safeguards this geological timescale. And, well, I can explain to you what the Anthropocene means, but actually I thought it would be good to show you a video. It might be easier. So let's have a look at this.
This is the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity, never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization.
So this gives you an idea of the Anthropocene. But I'm not going to focus on this, and especially not because it's still under debate whether this is going to be the new geological time period that we're living in. But it's interesting to use this concepts in a few ways. So if you look at like all these factors that they mention, and you see them here as well, there's things related to climate change like temperature, sea level, CO2. There's species extinction rate, which is basically where like the meteorite that killed the dinosaurs. But all these things are not so very visible if you go outside. And yeah, it's a bit vague to determine what they actually mean for us. And some things are more clear, more concrete. You can see them outside. For example, pollution. So maybe in the Netherlands not so much, it's quite clean here, but I noticed when I moved to England that these kind of pictures you see, the upper ones, you really see a lot there. And we're really putting a lot of plastic in the oceans. It's astounding to hear how much microplastics there is in soils, in agricultural soils around the world. So yeah, we're having all this impact. But what does all of this have to do with drought? And that is the stories that I want to tell you about tonight. So I'm going to give you some examples from all around the world. And well, of course, I've borrowed this title from another famous traveler, scientist / storyteller, Jules Verne. And well, we're going to see how the Anthropocene actually influences drought. So let's start close to home. Let's start in Europe at the River Rhine. Well, you might recognize the River Waal in Nijmegen in this picture. And when there is a drought in the River Rhine, then that has big consequences for navigation, for electricity production, for the ecology. So we want to know, if we want to manage the droughts in the Rhine, then we want to know what the causes of the drought are. And well, they could be many. So it could be a lack of rainfall in the upstream catchment. It could be a lack of snow melt and glacier melt in the Alps. Could also be related to maybe the Germans closing the sluices, holding back the water. Maybe it's the Germans drinking too much water, of course. Or a combination of those factors. So, well, if we want to manage, we need to know and we need to quantify these causes. And that is actually what we did in another area in Europe, in Spain. This is the Guadiana River in central Spain, or actually it was the Guadiana River, because, well, it now looks like this. The people living there erased the name of the river, and they made their vineyards into the riverbed. And that is because the river has not been flowing for more than 30 years in this particular area. And not only has the river not been flowing, also a very important international wetland dried up completely. And the nature organization that was responsible for that wetland said, it's the farmers. They are abstracting a lot of groundwater, and that is drying up the rivers and the wetlands. The farmers, they said, no, it's not us. It's because we had this lack of rainfall for a number of years. So we're not to blame for this drying up of the wetland. So then, of course, we needed to analyze and investigate. And, well, we found out that it was a combination of factors. So yes, there was a lack of rainfall over a number of years, but the abstraction of groundwater in this area made the drought 4 to 6 times more severe than would have happened only with this lack of rainfall. So yes, both the nature organization and the farmers were right, but actually the nature organization was a bit more right than the farmers. So these kind of things can help shaping the discussion about how to manage these droughts. It's not only important to look at the causes of a drought, how a drought develops, but it's also very interesting and necessary to look at, when you're in a drought, how to get out of it. So let's move to the US. And I'm sure you're all familiar with the famous drought in California that has been going on for quite a few years now. And the question there really is, when will it end? And the question you see in the media a lot is, how much rain do we need to end this current drought? And that's quite a difficult question. It's quite complex, especially because if you see the water system in California as a bucket that is half full or half empty, depending on whether you're positive or more a pessimist, then the amount of water you need, the amount of rain you need to fill up the bucket until it reaches the top again, is also dependent on how much water you take out at the bottom. So in this case, in California, they are taking out a lot of water. And I mean really fascinating amounts of water. And even during the drought, I think over the last year, they have drilled almost 3,000 new groundwater wells, only in this area in California. So my colleagues working in California, they told me that you don't actually see that there's a drought going on because it's so green. Because the groundwater pumping they use to irrigate the fields still gives them enough water, although they have to drill deeper wells and more wells to reach it. They still have all this irrigation going on, so a lot of green fields. There's actually another reason that California looks quite green still, and it's this. And I think this might be also the reason that Donald Trump says that there's no drought going on in California. But the amount of water you actually save by not watering your garden or by showering 1 minute less per day, that isn't really going to solve the issue. The issue really is the enormous groundwater abstraction for irrigation, for agricultural production in this area. And that is maybe not so eminent now, but it will have consequences for the future, and it also is having a lot of consequences for the ecosystem. So interesting interaction between humans and the water cycle in California. But it's not all doom and gloom in the Anthropocene. There are some positive sides to the Anthropocene as well. So I want to move to South America, where I want to show you an example of a more positive side. So this is Chile, the north of Chile, which is really arid. It's really dry there. But, well, because, as we said, drought is less water than normal, they can also still have droughts there. So they had a major drought in the end of the 60s, 70s, which prompted the government to build a big dam in this area. And that was a good decision, because afterwards they were able to supply water during a number of droughts. So the agriculture in this area could continue during a drought because they had water supply from the reservoir. However, they recently have been a bit worried because during small droughts it was okay, but now since 2008 they have had a number of years in a row without very much precipitation, so less precipitation than normal, and they see the reservoir levels going down. It's almost empty now. So even though the reservoir was okay during small droughts, it might not be sufficient during multi-year big droughts. So dams are, in that sense, interesting, and also they can be used for different purposes, and these purposes can sometimes be mixed. But we have to be careful. And for that, I will show another example in Australia, where a dam was built a long time ago in the east, near the city of Brisbane, to safeguard the city from severe flooding. And this dam was built to hold back the flood peak, which it did in a few times, but then the millennium drought in Australia, so the drought that started in about 2001 continued until 2010. And that drought made the water managers in the area realize that, well, we have this dam here, this big reservoir, and we're not using it because we want to save it for flood. Let's use it to store water during the drought. So they changed the operation of the dam to store as much water as they could, so that they would have water during dry periods. So that's what they did during this multi-year drought event. They tried to save as much water as they could in the reservoir, which meant that, well, the reservoir was quite full at the end of this period. And then when in 2011, a number of major rainstorms hit the area, the dam was full almost and couldn't hold back the floodwaters. And that is the reason that the city then got flooded. So this wouldn't have happened if they would have kept the water levels in the reservoir low, and they would have kept the dam for the purposes of flood protection. But because they changed it and they thought, oh, we can use this reservoir also during drought, they basically made the next flood worse. So it's an interesting balance there. And when I heard this story from some of my colleagues who've been investigating this event, I had to think about a similar situation we had in the Netherlands as well. I don't know if you might remember that, but if we go back to the Netherlands, do you recognize this picture? Yeah, what if I say Wilnis? Yeah. So this was a similar kind of situation, a complex balance between man-made structures, drought, and floods. So actually, when this happened, it was in 2003. I was doing some research in Ecuador. And I heard the stories from the Netherlands, and it was like, oh, drought, and it's so like hot, and there's no rain. There's like a heat wave and drought, and oh, it's all really, really bad. And then the next week it's like, we're having a flood now. How can this be? But of course, when I got back and people explained it to me, it all made perfect sense, because many of the dikes that we've built in the western part of the Netherlands are made of peat. And during this 2003 drought in Western Europe, this peat was drying out, shrinking and cracking, and that caused the collapse of this peat dike. So during a drought, the collapse of the dike caused a flood in Wilnis. And the interesting thing is that now, well, we're aware of this issue, so what we do now during a drought, we go out and irrigate our dikes. So basically we make the drought worse to prevent a flood from happening. So there's an interesting interplay between floods, droughts, and humans. Well, we've looked at different cases and positive and negative and complex interactions related to droughts and humans around the world, but I haven't talked about Africa yet. And that's not because there's no drought in Africa, you might be aware of that, but that's because, well, the relationship with humans is a bit different. And maybe we can say that the Anthropocene has not arrived in Africa yet. If we look at one example, in many rural areas in Africa, this is how water is used. This, of course, this way of collecting water using groundwater is not affecting the drought as severely as, for example, the examples in Spain or in California. But there's a big potential, a huge potential to also develop the water resources used in Africa, to use more groundwater, to support irrigation, to make more reservoirs, to make more water available for people. And this is a great thing. It also gives us the opportunity to learn from all our other case studies and learn from maybe cases where it didn't really work out so well and we were maybe making droughts much worse, to make sure that this doesn't happen in Africa. So we can hopefully exploit the water sustainably and making sure that we don't see the effects of our exploitation in the future or aggravating the drought for other water users. So hopefully we will be able to do that. And that brings us back, I guess, to also what the Anthropocene is. It's not only like a doom story and, oh, we're making it, we're destroying the world, but it's also like a positive thing. Like Selle has also mentioned, we can adapt and we can make sure that we make our world also very bright and positive. So let's see if we can continue this.
This is the story of how this relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
So, yeah, let's see if we can do that. We'll see in a few thousands, millions of years. So we've traveled around the world in a few droughts, and what I've hoped we've got from that is that we as humans influence extreme events like floods and droughts. It's not something that happens to us from above, but we interact with it and influence it. So it's not just a natural hazard, and there's like complex relations that we need to study and that we need to be aware of if we want to manage droughts in a sustainable way. So hopefully that will give you the overview of that. And I want to thank you all for listening. I want to thank Wageningen and Roel and the rector for inviting me here. And I want to thank a few colleagues who have, inspired me, gave me the inspiration and also the scientific evidence behind these stories in I guess, order of the length of their name. And also, well, I think nowadays we might not be able to travel around the world like Darwin has in his voyage, but we can do this virtually, like we did now this evening, and that is more environmentally friendly anyway. So, thanks very much for your attention.